All right, hello. Let me full screen this. Uh-oh, too early. Now I'm going to try to open my chat. Hello, hello, if you have shown up. Hello and welcome. Hello, hello. There are 4 questions down here that I'd like you working on. I will go over these, but in 10 to 15 minutes. Kind of depends on when people show up and when I can pull up my stream. Just need to log into my other account and subscribe. There we go. And we're in. Hello, everyone who says hello. Hello, Maddie. Hello, Rose. Hello, Michael. Hello, Chelsea. Hello, Sanjana. Hello, Dylan. Or I guess, hello, Dylan. Hello, Daikun and Keith. Oh, Keith, I meant to holler at you. I don't know if you did the first 2 free responses on the homework, but you didn't upload anything. So, if I have actually only graded 4th period for that one because I didn't grade them for the first one because these take a minute to grade. Hello, Nick. Hello, Kelly. So yeah, I just wanted to let you know that I kind of eviscerated you because you didn't upload. Yeah. uh, yes, I didn't see anything uploaded. Hello, Elizabeth. So yeah, normal deal. Hi, Tim. Uh, please try out these questions when you have finished. Please say done. Oh, I totally forgot something on question 3. Well, that makes question 3 a lot easier to answer. So, uh, whoops. I made 3 easier than I meant to. Seems good. Hi, Matthew. Hi, Raquel. I am not doing an AP classroom assignment because I need some time to catch up on grading AP classroom assignments. uh, so, yeah. Um, no AP classroom assignment this period, I guess. If you were here Friday, I think these are a little easier than Fridays. Yes, we are going over homework today. Quite a few people did very well. There were a couple problems on the homework, notably the L'Hopital's question, that did not go well for a lot of people. So that's worth taking a peek at for sure. Yeah, I probably should get music for this part of the stream. How did I do? Daikun, I don't know yet. I only graded 4th period, so... I have 1st and 3rd graded for the first assignment, at least the people who turned it in before I started grading it on Friday or whatever. And then I have 4th graded for this assignment. That's all I could finish this morning before I had to start prepping for this. So that is on my list of things to do. But after this, it's put in some Algebra 1 grades and respond to people. So if I do that, it will be later today or maybe tomorrow. Because tomorrow's the only day I don't stream. So it's a pretty chill day for me. The teachers and I had a virtual meetup. There were like 30 people there on Friday after our stream, like at 3 or something. And it was interesting to hear where everybody's at. Apparently, I am slightly more organized than the average Liberty teacher. Feels good. It's almost never the case. And I fixed my pen, so that's good. Yeah, I think 4 will be the hardest for people. We got some duns sneaking in here. Yeah, 3 was supposed to be harder than that. But, as is, it wasn't very hard. As per normal, we'll wait for a handful more duns before cruising forward. And we're still having people trickle in. Yeah, these are... It's like a few of these are a little bit hard to do in the head. Well, notably just question 1. Trying to figure these out ahead of time. Oh. Ooh. Another big wave of duns. Alright, I'll be going over this in like 30 seconds. Not garbage. Not very much garbage on here, Dokun. Oh yeah, I fixed my button. I got new batteries for my pen, so I can do snazzy stuff right now. That was 1 click. Feels good. Alright, turn off this mode. And I think I'm in business. Okay. For the first one, if you made u equal to x squared plus 1, then your du should have been 2x dx, so you just have 2 du's. And you can rewrite this integral as the integral from... And you could have just swapped this entirely to u and not substituted back in. If you put the bounds in the u substitution, u squared or 0 squared plus 1 is 1. 1 squared plus 1 is 2. And you can just leave it in a world of u's after this. You get 2 du over u squared, which you can rewrite as 2u to the negative 2 du. And then you just integrate, so it's 2u to the negative 1 over negative 1, evaluated at 1 and 2. And we get, what do we get? 2 times a half over negative 1 minus 2 times 1 over negative 1. Okay. So this last part is plus 2, and this part is negative 1. Negative 1 plus 2 is 1. Hey. That's a nice answer. Okay. Part 2. Notice how I didn't have to convert it back to x. That's a nice part about switching your bounds. If you switch your bounds, you can just plug in for u and save yourself a lot of hassle. So that's pretty cool. You didn't have to do that, though. You could switch back to x's. For the second one, if you take a derivative, you get 4x cubed minus 12x squared. If you take a second derivative, you get 12x squared minus 24x. If you take out a 12x, you get an x minus 2, which means 0 and 2 are my two pips, my possible inflection points. Then you just test on either side to make sure they're inflection points, make sure the second derivative changes on either side of them. And if we plug in negative 1 into this, we get negative times negative, that's positive. If we plug in 1, we get positive times negative, that's negative. If we plug in 3, we get positive times positive, that's positive. And so these are both inflection points, so x equals 0 and x equals 2. You could even say 0, 0, and 2, what do we get when we plug in 2? 16 minus 32? 2, negative 16? So we could actually totally find these inflection points. Points and all. That's 2. Okay, number 3. If you know the derivative, which is the rate of b's, then you just had to take the derivative of this. So to take the derivative of an exponential, you rewrite chain rule, natural log of the base. And this thing's always increasing, so the answer was just t is greater than 0. I meant to ask you when it equals the value, and I didn't. So this ended up being easier. The rate is increasing for every single moment that t is greater than 0. And then our fourth one, the hardest part of this was remembering what our boy arctangent looks like. An arctangent looks like a tangent that goes the other direction, like mya. And once you know this, you realize arctangent's small, but positive. And then, so if you take a huge positive and divide it by a really small positive, you get a huge positive, so the answer is infinity. Out of curiosity, how did people do on this? I think there were some relatively tricky ones on here. Not two, but some of the other ones were tricky. Any feedback? Subpar, 100%. I wonder what par is on a question like this. or a warm-up like this. Maybe 50% is par? I don't know. Number 4 is not L'Hopital's. No, arctangent doesn't go to infinity, actually. Arctangent it goes up to pi over 2 and asymptotes to it, and negative pi over 2 on the bottom end. So, because the bottom isn't going to 0 or infinity, it can't be L'Hopital's rule. The top is going to infinity, but the bottom's going to pi over 2, which is why it goes to infinity. So sorry, no. 4 is not L'Hopital's. You think 3 is par, Liam? Interesting. I think you'd, well, actually, most golfers shoot over par, so maybe that's normal. Okay. On 1, how would you do it without changing the bounds? Okay, so how you would do it is you'd leave the bounds in terms of x, like mia, and we have the same du and u stuff, like this. We'd integrate to the same thing, 2u to the -1 over -1. We just plug in x squared plus 1 again. So x squared plus 1 to the -1 over -1, and we're plugging in 0 and 1. And if you plug 0 and 1 into this, you get exactly the same thing. It's 2 times 1/2 over -1, and if you plug 0 in, you get 2 times 1. So it's exactly the same when you plug it in. Proof that they're the same. So it's not harder that way. Got a double bogey on that warm-up. That's good, I guess. All right. All right, I want to pop over and not do that yet, but rather go to not that, but this. This is the homework. I downloaded the document that is the homework, all the questions and stuff. So I kind of wanted to go through what were the most commonly missed questions on here. So that starts us off on question 1. Honestly, most people did really well on question 1. I was pretty happy with that. Almost everybody got the first part right. Almost everybody got at least part of the second part right. The second part required a little more nuance. In that you were given dHdt is -1 over 10 root h, and if you take the derivative of that, you get the second derivative. Because you're trying to find when the rate is increasing or decreasing, and that's the second derivative. Is it concave up or concave down kind of idea. And if you take the derivative of this, you get 1 over -10 times 1/2. How is that showing up? Okay, the contrast is truly terrible though. Times h to the -1/2 dHdt. And the key part here was the dHdt, because then you plug in -1/10 root h again, and the h parts cancel, and all you get is 1 over -10 times 2 times -10, which is 1 over 200, which is always positive, so it's always increasing. And so that was the first part that foiled some folks. And then for C, the separation of variables one, tons of basically everyone separated variables right. There were a couple goofy mistakes finding plus C, and notably what a lot of people did was either squared both sides and individually squared both the C and the number, or solved for C in one step and plugged it in another step. So to show that real quick, if you separate variables, which is step 1, you should get h to the -1/2 dH equals -1 over 10 dt. You integrate both sides and you get h to the 1/2 over 1/2 equals -1 over 10 t plus c. This is the same as multiplying by 2, so we could divide by 2 on both sides, and we get h to the 1/2 equals -1 over 20 t plus a different c. And here we could solve for c by plugging in 0 for t and 5 for h, so c is just the square root of 5. It's pretty nice to plug in there because this becomes 0. And all you have to do for the last part is solve for h, which means we got to square both sides. So if we square the left side, we just get h. If we square the right side, we get the right side squared, so -1 over 20 t plus root 5. So some people tried to square each of those things individually and get like 1 over 400 t squared plus 5, but that's like super illegal. And that was the other common mistake on that. Okay, second question was a lot harder for folks, at least one part of it was. So question 1 went pretty well for folks on average, I would say. So in this, they give you some information about these things. So we have F, G, and H. They're differentiable everywhere, which means we can do all calculus on them. They meet at 4. G and H at least meet at 4. And then whether or not the other part meets is, I think, part of D. And then we have this line that's tangent to the graph. So that tells us something pretty useful. It tells us G's slope and H's slope. And they both have a slope of 2/3 if this is their tangent line. And so that's literally A. It's just like, what's the slope? And it's like, oh, the slope is 2/3 in that equation, and it's tangent to both of the graphs, so huzzah. Next one, we bring in a new variable. It's equal to this garbage, so we're going to have to do some product rule. The people who got this wrong generally did not do product rule. Daikun, it's a reading question. It's, do you understand those two parts are equivalent? If you do, it's a very easy question. If you don't, it's actually pretty hard. So it kind of depends. Okay, so that's a prime b. 3x cubed's derivative is 9x squared. Plus 3x cubed times h prime of x. That's ab prime. And then we just chuck in 2. So we get, what, 36 times h of 2, but h of 2 is 4. And 3 times 8 for x cubed times h prime of x, but h prime of 2 is 2/3. Cool. And we just get 36 times 4, which is 144, plus 3's cancel, so 16. And so that's 160. Okay. A and B were the nice parts of this question, and actually a ton of people got these right in the one class I graded. Now C is where things started to fall apart. C says the function h satisfies h equals x squared over 4 over 1 minus f of x cubed for x is not equal to 2, because the idea is that if you plug in 2, it's 0 over 0. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. The reason why I know it has to be 0 over 0 is if you plug in 2 here, you get 0. And so the bottom would have to be 0 for L'Hopital's rule to work. And it says it can be used with L'Hopital's rule. And then it says use this idea to find f of 2 and f prime of 2. So those are the two pieces of the puzzle I want to figure out. F of 2 is a lot easier. All we need to do to find f of 2 is take this bottom of the equation, 1 over f of x cubed, and I want that to equal 0. So all I want is I want f of x to be equal to 1. So f of 2 is 1. That's it for that part. And then for the second part, f prime, if L'Hopital's works on this, I can take the derivative of the top and the bottom independently, and then reevaluate this. So, okay, I take the top derivative of the top, it's 2x. I take the derivative of the bottom, it's negative 3 times f of x squared times f prime of x for the chain rule. In the first part, I figured out f of 2 equals 1, so I can simplify that part, no problem. The top is 4 when you plug in 2. The bottom is negative 3 times 1 squared, which is 1, times f prime of x. And the thing is, I know more than this, because our function h here is equal to this nonsense. Where am I? I got a little turned around here. Oh, yeah. So h has a slope of 2/3 at 2. So I know L'Hopital's should give me 2/3. So I should be setting 2/3 equal to 4 over negative 3 times f prime of x. Okay. Or f prime of 2, whoops. Because I should have plugged in 2 for x as well, there. And now we just solve this equation. And we get, what, 12 equals negative 6 f prime of 2. So I got f prime of 2 equals 2, which is wrong. What did I do wrong? Blast. I goofed. Because f prime of 2 is not 2, and that is trash. Why am I dumb? Carry the 4, I think. Yeah, I think that is my issue. I am really acing things today. Oh my gosh, oh my gosh, oh my gosh. Did I really make that mistake? Oh, yeah, okay. So here's the part that Mr. Kennedy did dumb. L'Hopital's tells us what the function's going towards, which is 4, not 2/3. So what I did trash-wise is this should have been a 4. Because that's what L'Hopital should equal. L'Hopital should tell me what the limit of the function is, which is what the value of the function's approaching is. So that was a little sloppy. Oopsie daisy. Now if we solve this equation, I'm going to get, what, negative 12 f prime of 2 equals 4, so f prime of 2 equals negative 1/3. Yeah, that's right. So I just goofed and set it equal to the derivative because I had taken a derivative, which is really a silly mistake. L'Hopital's rule helps us evaluate limits, which is the value of the original function, not derivatives, even though we take a derivative. And that is the primary issue. Very few people got this right, by the way. And you can tell why, because if I had a hard time with it, it's because it's hard. This was a hard question. Don't feel bad. If you made the mistake I did, you probably got 2 out of 4 on that question. If you got to this end part, you had to set the L'Hopital's part equal to 4 to get the third point. I graded this and I still got it wrong. Feels bad. Alright, down to our bottom two. or bottom one. This one was actually really easy. So A and B, not too bad. C, pretty brutal. D, back to easy. Because it says there's another function, k of x, which is always either equal to or in between g of x and h of x. Is k continuous at 2? And all we have to do for this is, I think Michael talked about this in his, but there's this thing called the squeeze theorem, which is a super stupid theorem, but it is the key word to use on this one. Most of you described the squeeze theorem, so I give you credit for it. But basically, if g of x is 4, and h of x is 4, and their slopes are the same and like everything, they're both twice differentiable, and equal, well, then if k of x is in between them and they're both 4, then k of x has to be 4, and it has to be continuous because both of those functions are continuous and it's always in between them. And that's it. There's really nothing more to that. And so, yeah, shout out to Michael because he mentioned the squeeze theorem. That's what the squeeze theorem is if one function is in between two others and then they meet at a point, the point they meet at has to be this, like, this guy has to also be that point, which is really lame. It's such a stupid theorem. It's like the ultimate in common sense. Yeah. How do you know they are 4? Oh, Liam, in the question at the very beginning, it says they're both 4. Sorry. G and H are 4. That's what makes this one of those kind of no-brainer questions. Like, everyone said it was continuous, which is good. It's just the reasoning, mentioning the squeeze theorem is a pretty good idea to do. Can you do C again? Sure, I'll give a Cliff Notes version of C. In C, you need this to be 0 over 0. So you just solve for the f of x value that gives you 0, which is 1. Second thing, you need L'Hopital's to work. And when you take the derivative of the top and bottom, it's going to give you the limit for what the function should be at 2, which we know from what I was just talking about in D is 4. So all I do is I set 4 equal to the L'Hopital's, the derivative of the top and bottom, which is -3 times f of x squared times f prime of x. And you chuck in a 2 for all the x's, and you get 4 equals 4 over -3. F of 2 is 1, and f prime of 2 is what we're trying to solve for, and you just solve this equation for f prime of 2. And that's it. That's the Cliff Notes version of that question, now that I'm not running around in circles. What is the 4? 4 is the value the function equals. H equals 4 at 2. Notice how C is asking about f, which is why f of 2 is 1. It's something different than 4, but for G and H, they're both 4 at 2. And so it's just given in the question. Okay, the other one that people had a bit of a hard time with was actually not a lot of these other ones, because these were fairly family friendly. I tried to, basically, there aren't that many full FRQs on the AP Classroom thing that are not off of unreleased AP exams that I'm not supposed to give you as homework. So I have struggled a little bit to find them, so I tried to make one out of 4 different questions at the end here, so it counted as 3 free response questions. And this was the hardest at bat for people usually, was this one. And 5, what you needed skill-wise for 5 was that the integral from 0 to 5 of this whole thing here is the integral from 0 to 3 of the first thing, plus the integral from 3 to 5 of the second thing. That's how we do piecewise functions. We just do two different integrals, one for the first part, one for the second part. Once you've done this, because you're trying to find average value, you got to divide the whole thing by 5. So that was that question. If we integrate, we get x plus 1 to the 3 halves times 2/3, evaluated at 0 and 3. You can chuck a 3 in there, and you get 2/3 times 4 to the 3 halves, minus 2/3 times 1 to the 3 halves. If you integrate this, you get, 5x minus x squared over 2. Plug in a 5 and a 3. And you get 25 minus 12.5 minus, I'm going to go on the gray again, 15 minus 4.5. 4 to the 3 halves is 8, so this is 16/3 minus 2/3. If you don't remember how to do that, remember the square root of 4 is 2. 2 cubed is 8. That's how you do 4 to the 3 halves. Plus 12.5 minus 11.5. Oh, the math just got easier. Cool. So that's plus 1. 16/3 minus 2/3 is 14/3. Wait, Mr. Kennedy, did I get so bad because I didn't show work? Yeah, I can't give you any intermediate if you don't show work, so, rip that if you don't show work. Feels bad. Can't give you credit. Alright, so we get 17 over 3 when we add these together. And you divide by 5 for the average value, and you get 17 over 15, or 1 2/15, which was the answer they had, 1.1667 or something like that. Which was what most people answered. Who got this right? Can you post the answer key for the homework? I'll try. I may need to password protect it, because I'm not sure how many of these I'm allowed to release answer keys for. I will try. And yeah, you just type the answer, Liam, and then you got some of them wrong, and so I could give no partial credit. So yeah, I just grade them binarily if you just write the answer. Okay, and then otherwise, I think the rest of it went well, unless anybody has any questions. Do you have to combine the two functions at the end, or can you do it earlier? You can do it earlier. That's fine. I think they are all off former AP tests. Yeah, probably. Not all of them. Some people write questions. Like some AP teachers write questions and put them on the AP Online thing. So it depends. No questions. It was a solid 15-20 minutes on homework there, so that makes sense. Okay. The second one of those, Johnny. Differentiable is the big boy. Continuous is the one that's dependent. Continuous is just the original derivatives or the original function's continuous. Differentiable is they're both continuous, both the derivative and the original function. So twice differentiable is like the big kahuna. It's why all calculus works. If you see twice differentiable, you just know you can do everything, all the tricks, and that's pretty cool. Hi Ryan, and yeah. It's okay if you were too lazy. If you upload them, they will get graded. I can't guarantee when. Now I have this question. This was brought to my attention last Friday and is a pretty good question. So this is the free response question I would like you trying out right now. This is a calculator allowed question, which helps a lot because integrating that mess would suck without a calculator. And getting quite a few of these answers would suck without a calculator. But I would like you to try out this problem. The homework I have for today is just AP test questions. It's going to be, I'm going to post solutions for it for sure because they're like very easy to Google. In fact, I think most of these questions are pretty easy to Google. But yeah, I'll be posting the solutions for this. The homework I'm assigning tonight. I just took the 2007 B exam, which we have already done 2 of the questions off of, and just took the other 3 questions. So that's the general rule is in between all these classes, I'm going to be assigning 3 free response questions. And this one was brought to my attention by a student, I think it was Maddie, who emailed me Friday and asked about this question. And this was on the AP tests in 2018, so just a couple years ago. So this is the one TJ took. And this was definitely one of the more meme questions. The hardest questions are generally called meme questions on the AP tests, you know. So that was this one. Yeah, how would I upload solutions to this? Oh man. Take some computer work on my part. Maybe a lot of snipping. AP Classroom does them weird. Another moment where it should have some music. Rats. Calculator? Yes. This is a calculator question. It would suck without a calculator. A is actually surprisingly nice, but the other parts are all janky decimals. And finding A without a calculator is also not easy. I think if you tried to do that without a calculator, I think the play is actually to expand everything with Pascal's triangle and then integrate each of those parts separately, which does not sound fun, so please use a calculator. That's scary. Huh. What's scary? The silence. Oh, hello, Nick. Welcome. Integrating this without a calculator. Yeah, true. I don't think it would be that horrible. No, it'd be horrible. It'd be horrible. No, kind of. I think you could do it without a calculator. It would take 20 minutes or so, probably, to do. Maybe less. Thank goodness for Pascal's triangle for situations like this. Doing this without Pascal's triangle would actually take 20 minutes or 30 minutes or something. Wonder if I should do the equivalent of calling people up to the board for this. That'd be entertaining. Certainly for A, I could do that because it's just an answer. I mean, kind of. They're showing your work and then there's the answer. So yeah, just a warning to the Liams and Jacobs of the world, since those were yeah, Liam said he just uploaded documents. Yeah, no, a couple people were just typing answers into Word documents and uploading those, and you should practice not doing that for the AP test because the way we upload it on these assignments is actually exactly how you're probably going to do it on the AP test. So it's really good practice. No thanks on the calling on people, man. Okay. I could post somebody as a good example. I have had quite a few pretty good examples of people doing this. If anybody wants to see what a pretty easy to read version looks like, could do that. Oh, that'd be kind of a cool answer key. Just post people's work. Feel free to type done in when you are finished. No rush. Desmos makes this a lot easier. don't have a calculator, Liam. Are you not on a computer? Are you on your phone? Because if you're on a computer, you could like Alt-Tab this and bring up Desmos. But if you're on your phone, that might be a little harder. Yeah, please realize Desmos is a thing, because you'll be allowed to use Desmos on the AP test as long as you have another computer that isn't the one with the secure browser that you're using, although maybe they'll have Desmos built in? Unclear. Yeah, I don't remember. I should watch things. Maybe one of you has watched a stream where they answer that question. The good news is we're still a month from the AP test, so I mean, if you're starting to feel like you're getting better at these, that's killer, because you still have a month to get better after this, which is... We went from... Like, we're ahead of schedule. Things are actually, for AP Calculus, doing great. You use your graphing calculator? That works too. Finding intersections is just easier in Desmos than it is on your graphing calculator, and that can help you on a couple of these questions. Do 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 do. Oops. Points-wise, this question is 2 for the first, 2 for the second, 1 for the third, and 4 for the fourth. So the fourth is supposed to be the biggest question. Our first 2 duns trickled in that didn't have a head start. I hate Cortana too. I agree. Both Cortanas, isn't that the one in Halo? I think so. And in this. Or in Microsoft Word. They're both Microsoft. Whoa. Crazy. No, not the Halo. Yeah, I didn't play enough of that game to hate Bixby, I think. So. Whoa. That's a blast from the past. I didn't notice that last name. How many years ago was that? Holy smokes. Oh, it's because you had not commented. Okay. But I don't want to be called... Yeah, I probably won't call on people. Wasn't Bixby also from... Is that not the name of the thing from... I was thinking like Borderlands, the little robot dude. No, that's not that. 4 years ago. Okay, okay. Hello, later. All right, probably start going over this in 1 minute. We're at like 5 dones. 6 dones, 5 dones, 5 dones. So about 45 seconds now. And then the stuff will begin. This is definitely a question where a lot of people got part of this right and didn't get other parts of this right because it's very good at structuring the difficulty. Like, all the parts are difficult in different ways, so pretty nice to get. I'm not staying 1 minute after 2. Oh, rip. All right. I assume you have another thing at 2? All right. Let us begin. The first one. All you do is integrate this from 0 to 300 on your calculator or in Desmos. If you do this, you get 270 people. That's it. That's question 1. I guess 270 people enter the escalator, or get on the escalator. Wow, enter. Who says that? Oh gosh, and I can't spell. Escalator. From t equals 0 to t equals 100, or 300. So in the first 5 minutes, you could say. That's A. And they gave 1 point for doing the integral, and 1 point for the answer, with units and all that crap. Do you add 30? No, you don't. And Liam answered that right. And the reason why is because the number of people entering is the integral. The number of people total who are on the escalator was the 300, or the 30 plus that, or 20 plus that rather. So it's only the people who enter. So how many people are in line at t equals 300? What we're going to do for this one is well, it doesn't actually require a lot of extra pieces, because the only piece we're adding is we're going to say there are 20 people on there at the beginning. We add 270 people, because that's how many people enter from 0 to 300. And then we're going to subtract the amount of people that come off, and that's this. So the amount of people that exit the line, 0.7 times the time, which is 300. And so the number of people that come off is 210 people, so there are 80 total people in line. 80 people in line at t equals 300. Do we have to state our answers with context like that? You should. I think 80 people would be fine, but their answers look like this, and so the more you can look like their answers, the more likely you are to get credit. Moving on to the third part. What is the first time t when there are no people in line for the escalator? So that first time t happens after people stop getting on the escalator here, because 0 people enter for times after 300. So we know there are 80 people in line at t equals 300, and we know we subtract 0.7 every second, and you just solve for where this equals 0. So it's 80 divided by 0.7 is the time, and 80 divided by 0.7 is the time after 300, so we'd have to say 300 plus this. And so that decimal, if you get the decimal, you don't need to. You can say 300 plus 80 over 0.7 as an answer, with units correct. Or you can write 414.286 seconds. You can also put 285 because this is the rounded answer and this is the truncated answer for C. So no calculus required for part C. It's literally just there are 80 people on at the end, and then they just keep filing off linearly, and you just figure out when. So not too bad. Last part, which was kind of the heaviest part, difficulty-wise, because you actually had to put this, like, graph this in your calculator. We know the number of people on the escalator at any given time is 20, because that's how many start, plus the amount of people that go on, so 0 to some time of the garbage. T over 100 cubed times 1 minus t over 300 to the 7th dt. So that's the number of people going on, and this is the number of people coming off. And I would have to integrate this from 0 to t, which means I'd actually need to expand this whole thing out if I actually wanted to find the number of people. But I want to figure out at what time t is the number of people a minimum. And minimums happen when the derivative equals 0 at relative extrema. So I'm going to take the derivative of this equation, and this is much easier to do. Because if I take the derivative of 20, I get 0. If I take the derivative of something with a variable in the exponent, this is just our boy, the second fundamental theorem of calculus, we just plug the t in. So you just get 44 times t over 100 cubed without the integral, times 1 minus t over 300 to the 7th, because I took the derivative of that integral. And then minus 0.7, that's the derivative of 0.7t. And all you do is graph this on your calculator and see where it goes through 0. And where this goes through 0, if you graph this on your calculator or on Desmos, is at 33.013 seconds. So, yeah. Then for the minimum, you have to test the critical points and the endpoints. So 33.013. And oh crud, there's actually a second point on my graph that comes before 300, which is our endpoint, which is 166.574, because the graph, if you look at it, looks a little something like, you have to zoom out quite a bit, but it like goes up and then comes down again. And it's helpful to do this in Desmos because you can zoom out really easily. The graphing calculators are not easy to zoom out on, so don't feel bad if you're not good at that. We know there are 80 people at 300 because that was the answer to let B. We know there are, how many people at the first time? 20 people at the first time. And then all you do is plug these into the time. So you do the integral from 0 to 33.013. Like 298, use all your decimals of this thing. And you figure out how many people went on at that time, and then add 20 to it and subtract 0.7 times t. So we're basically just solving this huge equation by plugging in 33 here, the 33.01329, whatever. And then we're going to plug in 166.574. And if you plug in both of these numbers, you get like a big number for 166, so there are a ton of people in line at this time, and you get a much smaller number at 33.013, which is like 3.8 people, so like less than 4 people, because 3.8 is a really confusing number of people. And so our final answer is, because 3.8 is a garbage answer for number of people, we just say there are 4 people in line. In line at 33.013 seconds. And that's how I'd answer that question, not 3.803 people. Is it absolute minimum? Yes. When it says when is the number of people in a line a minimum, they're not asking for like a relative minimum when there's like a random low point. They're asking for the minimum. And so that's what makes that different. Why didn't you take the integral of 0.7t? I don't. I take the derivative, which is why it's 0.7. 0.7t is the integral. 0.7 times time is the integral of 0.7, which is the rate of people exiting the line. So it is an integral, 0.7t in itself. And that's that. It looks like I went a little past and my numbers started dropping. Feels bad. I did want to point out the homework real quick. On the homework calendar, I just linked to some AP questions. The AP questions I linked to were... Oh, crud. Did I close my windows? Well, the questions I linked to are on my homework calendar. It's just 3 AP questions. I have it in my documents, so I can just go look there. Yeah, it's just 3 questions, so 1 question. Oh, this is not the right question. Why did I open this? Date modified. Oh, I didn't put it in my documents. All right, well, the point is there are 3 AP free response questions on there. Those are what I'd like you doing. I'll post the solutions document for those, like right now. And that's what I would like you trying out for this, between these. And in that time, I'm going to try to catch up on grading your free responses that you posted online, because they take a minute to grade. So I will get on that. And anyways, I'll see you Wednesday, folks, when we'll just do this thing again, and I'll talk about those 3 responses. Adios.